Solving multi-step inequalities. At the end of the lesson, you should be able to answer, how do I solve multi-step inequalities? Additionally, you should be able to write an inequality from a word problem and graph its solution. Please remember, at any point that you multiply or divide both sides by a negative value, you must reverse the direction of the inequality symbol. So this concept that we learned in previous lessons will still apply. So in the first two problems, we're going to look at how we solve and then represent the solution on a number line to these two inequalities. And really, it's exactly the same as solving an equation. So our goal is to isolate the variable in the first one, so I'm going to begin by adding 7 to both sides, which results in 3x is less than 15. I then divide by 3 and get x is less than 5. Since there is since I did not divide both sides by negative, I do not need to reverse the direction of the inequality symbol. So I am simply going to draw my number line. I'm going to place a few values on it. So I'm going to put 4, 5, 6 and graph everything that is a solution. So I am going to use an open circle for, just see here. Just undo that. Going to use an open circle on 5, and I'm going to shade all the values less than so they are to the left. In number 2, I'm going to need to get rid of the parentheses, so I'm going to distribute in this problem. This is going to give me negative 1/4 m, and I have a negative times a negative is going to make this a positive, and 1/4 times 12 is 3. And then that's greater than negative 2. Isolate by subtracting 3 from each side, and I get negative 1/4. M is greater than negative 5. To finish this is held by multiplication, but I'm going to do the inverse, which is division, but I know that dividing by a fraction is the same as multiplying by its reciprocal, so I'm going to multiply both sides by negative 4. Negative 4 times negative 1/4 is positive 1, m. Negative 5 times negative 4 is positive 20. And this is a scenario where I must reverse the direction of the inequality symbol because I did divide by a negative. Okay, so I'm going to graph my solution. And this one again is going to be an open circle because I have, because it's just less than. So again, if I put 19, 20, 21 on my number line, I'm going to put an open circle and I shade all the values less than. Just a quick reminder, if it would be less than or equal to, you would use a closed circle, or even greater than or equal to. Okay, let's look at an application of this. It says, a nurse has worked 7 hours so far this week. If the remaining shifts for the week are each 4 hours long, how many possible full shifts can she work if she can work at most 24 hours this week? So, she currently has worked 7 hours. She's going to work additional shifts that are each 4 hours. So I'm going to say plus 4x. So in this case, x is going to represent the number of 4-hour shifts. 4-hour shifts. And it needs to be at most 24 hours. So the phrase at most means less than or equal to. There's my inequality. And now the steps for solving become pretty easy. So I have 4x is less than or equal to 17. And then I divide each side by 4, and I get x is less than or equal to 4.25. Now the question is, how many possible full shifts can she work? Well, if x is less than or equal to 4.25, if she has to work a full shift, it can't be 4 1/4. So she can work at most 4 shifts. So it's important to make sure that you've answered the question that's being asked to interpret this inequality. Now, let's look at some problems where we have variables on both sides of the inequality. And there are some tips I've given you on your note sheet. First thing you want to do is, if there's parentheses, you're going to apply the distributive property. If there's not, you're going to look for any like terms that occur on just one side of the inequality, either here or over here. Now, we don't have any any like terms on either side, so I'm going to go to step 3. I'm going to use inverse operations to move my variables to one side and my constants to the opposite. I like to move my variables to the left, so I'm going to subtract 2x from each side, which results in 4x minus 7 is greater than 17. Then I add 7. I get 4x is greater than 24, and I divide each side by 4 to finish it, and I get x is greater than 6. Again, my solution needs to be graphed on a number line to show all the possible values that are true here. I'm going to number my line by 2's, so 4, 6, 8. X is greater than 6, so it's all the values over here. So they get really close to 6, like 6.01, and they go forever to the right. In this next one, where I do variables on both sides again, but I have parentheses this time, I'm going to begin by distributing, which gives me negative 5x minus 20 is greater than or equal to 3x minus 12. Again, variables to one side, so I'm going to subtract 3x, which results in negative 8x minus 20 is greater than or equal to negative 12. Add 20, which results in negative 8x is greater than or equal to 8. If I divide both sides by negative 8, I get x, I get negative 1, and it is necessary for me to reverse the direction of the symbol because I divided by a negative. So when I graph my solution set, I have negative 2, negative 1, 0. This time it will be a closed circle because x can equal negative 1. And I shade all the less than values which go infinitely to the left. Let's look at an application now where we will have variables on both sides of the inequality. It says Anna sells funnel cakes at the county fair. She is to rent the equipment for $46 and spends 48 cents on ingredients for each cake. What is the minimum number of funnel cakes Anna must sell at $1.50 each in order to make a profit? Write and solve an inequality to determine this. Well, think about profit. Oops, let me just go back here. In order to make a profit, what you're going to need to do is whatever you sell something for has to be greater than the cost to you. All right? So I wrote this little general inequality here, and I'm going to need a variable, which in this case I'm going to use C for the number of cakes, or funnel cakes. Number of cakes. Let's see what she sells them for. It says she's selling them at $1.50 each. So I'm going to say 150 C for each needs to be greater than, well, the cost is $46 plus 48 cents for each funnel cake that she makes. There's the most difficult part, in my opinion. So let's just solve it now. I'm going to subtract 48 cents from each side, or 48 cents C, which would be $1.02 C must be greater than 46, and I divide both sides by 1.02 to isolate the C, which gives me C greater than 45.1, approximately 45.1. So this means that Anna would have to sell greater than the 45.1, so she's going to need to sell at least 46 cakes in order to make a profit. Now, we need to just examine two possible scenarios that might happen. Sometimes, just like in equations when you're solving, all of the variables just drop out. The first thing you want to do is make sure you didn't make an error somewhere. But if the variables drop out and you're left with a true statement, like 4 is less than 16, that means every possible value will satisfy the inequality, so the solution would be all real numbers. Whereas if you get a false statement, like negative 5 is greater than or equal to 6, that's not true. Well, that means you'll never find a solution that works. So let's look at these two special cases here. I'm going to start by distributing, which gives me 5m plus 25 is less than 5m plus 17. So to solve this, I'm going to subtract 5m from both sides because I want to get my variables together. Well, what happens is the m's, or the variables, completely drop out, and I'm left with 25 is less than 17. This is not true. 25 is not less than 17, so there is no solution that will ever satisfy this inequality. Whereas in the final example on your note guide, if I distribute -4, 1 minus 8f is less than or equal to -8f plus 4. If I add 8f to both sides, my variables drop out and I'm left with 1 is less than or equal to 4. This is true. So this means that your solution is all real numbers. So since every possible value would satisfy this inequality, if you go to graph the number or graph your solutions, you would just shade the entire number line. Okay, you should now be able to solve a multi-step inequality.